Picture a solid iron ball, hotter than the surface of the sun and larger than Pluto, suspended in a sea of liquid metal. It's scorching nearly 10,000 degrees Fahrenheit and crushed by the weight of the entire world. For billions of years, this inner core has been the Earth's silent engine. But recently, the heartbeat of that engine skipped. For the first time in recorded history, scientists have watched the Earth's center slow down to a crawl, stop, and then start to rotate in the opposite direction relative to us. It sounds like the plot of a disaster movie, but the reality is much more fascinating. It's not an ending, it's a cycle. And it's a cycle that controls the very ground you stand on.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
To understand why the core is changing, we first have to understand the sheer impossibility of studying it. We've sent probes to the edge of our solar system, yet the deepest hole we've ever bored into the Earth is only about 7.6 miles deep. That's barely scratching the skin of the apple. The inner core sits 3,000 miles down. We can't see it, touch it, or send a camera to it. So how do we know it's moving at all? We use the Earth itself as a giant ultrasound machine. Every time a massive earthquake strikes, seismic waves ripple through the planet's layers. By measuring how these waves change speed and direction as they pass through the center, we can see the core's density and its movement. But in the late 90s, scientists noticed something strange. The waves weren't hitting the same way they used to. In 1996, a landmark study changed everything. Researchers realized that the inner core wasn't just sitting there, it was super-rotating. This means it was spinning slightly faster than the crust and mantle where we live. Imagine you're on a merry-go-round, but the center pole is spinning even faster than the platform you're standing on. This was a massive discovery. It proved that the inner core is decoupled. It's floating in the liquid outer core, free to move at its own pace like a marble in a jar of thick honey. But if it's floating freely, what is actually pushing it? The liquid outer core is a churning ocean of molten iron. This movement creates massive electrical currents, which in turn create the Earth's magnetic field. This field doesn't just point your compass north. It exerts a physical push on the solid inner core. It's essentially a giant electric motor. The magnetic field pushes the inner core to spin faster, but there's a counterforce, gravity. The mantle, the thick, rocky layer above the core, isn't perfectly smooth. It has lumps of different densities that gravitationally pull on the inner core, trying to slow it down. For decades, the magnetic push was winning. But around 2009, this cosmic tug-of-war reached a stalemate. By analyzing decades of earthquake data, specifically doublets, repeated earthquakes that happen in the same spot years apart, scientists found a shocking trend. Between 1980 and 2000, seismic waves traveled through the core at changing speeds, meaning the core was rotating. But starting around 2009, that change stopped. To an observer on the surface, the inner core appeared to have stopped moving entirely. It had synchronized perfectly with the rotation of the Earth's surface, but it didn't stay still for long. It was just the peak of a swing that is now moving backward. The leading theory now is that the core doesn't just spin faster forever. It oscillates. Imagine a pendulum swinging back and forth. It speeds up, reaches a peak, stops for a split second, and then swings back. Scientists believe this cycle lasts about 60 to 70 years. We saw a similar pause and shift in the early 1970s. This means that for about 35 years, the core spins slightly faster than the crust, and for the next 35 years, it spins slightly slower. From our perspective on the surface, it looks like it's reversing direction. This might seem like a distant geological curiosity, but it has a measurable effect on the length of your day. The Earth is a closed system. If one part of the Earth slows down, like the inner core, another part must speed up to compensate. When the core slows down during its 70-year cycle, the rotation of the rest of the planet, the part we live on, actually speeds up slightly. We're talking about a change in the length of day by a fraction of a millisecond. It's too small for you to feel, but it's enough that GPS satellites, which rely on nanosecond precision, have to be constantly adjusted. But the core doesn't just affect time, it might be affecting the very climate we live in. This is where the story takes a controversial but fascinating twist. When scientists overlaid the 70-year core cycle with other global data, they found some coincidences that are hard to ignore. The cycles of global mean temperature and sea level rise seem to track remarkably well with the core's oscillation. While the core isn't the primary driver of climate change, its movement shifts the Earth's magnetic field and its gravitational center. This can slightly alter ocean currents and atmospheric circulation. Everything is connected from the molten iron at the center to the clouds in the sky. Perhaps the most critical role of the core is maintaining our magnetosphere. This invisible bubble protects us from solar winds that would otherwise strip away our atmosphere, turning Earth into a barren wasteland like Mars. As the inner core changes its rotation speed and interacts with the liquid outer core, the geodynamo, the process that creates the magnetic field, fluctuates. We know the magnetic poles move, and we know they've flipped entirely in the past. Understanding these 70-year wobbles helps us predict if our shield is weakening or just resetting. So, should we be worried about the core reversing? The short answer is no. This isn't a sign of an impending apocalypse. In fact, it's a sign of a healthy, living planet. A planet with a stagnant core is a dead one. The movement, the friction, and the tug-of-war between gravity and magnetism are what keep the Earth's interior hot and its magnetic field strong. The reversal is just a phase of a cosmic dance that has been happening since long before the dinosaurs. We just finally have the technology to watch it happen. It's a humbling reminder that we are riding on a massive, complex machine that still holds secrets 3,000 miles deep. The Earth's core proves that even the most solid things in our lives are in a state of constant, rhythmic change. We are learning that the rhythm of the deep Earth dictates the rhythm of our time and our protection. If the Earth's core can change direction without us even feeling it, what other massive shifts are happening right now that we've completely missed? If you want to see how other invisible forces are shaping our reality, you should check out our deep dive into the Great Attractor, the mysterious force pulling our entire galaxy toward an unknown point in space. Stay curious. To keep exploring the mind-blowing facts that run our world, make sure to subscribe to MindSpark. We'll see you in the next one.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas and tell me in the comments what topic we should explore next. Until next time, keep your mind curious,